Okay, in this video we will be deriving the formula for arithmetic series. In the last video we actually used this formula, but in this video we're going to derive this formula. So just to get our head in the right space, so let's say we have this sum of the series, 1 plus 3 plus 5 plus 7. If you notice, each number increases by 2. And so I can say that sum is equal to a sub 1, the first number, say 1, plus, see the next number increased by 2. So it's a sub 1 plus 2. The next number increased by 2 again. So plus a sub 1 plus 2d. So if this piece increased by 2, if you compare 1 and 5, it increased by 4. And so 2 times 2. So 2 times 2 would give us our 4. And then the pattern continues. So eventually you would have a sub n minus d plus a sub n. So the very last term is a sub n. But the term before the last term would be minus d, a sub n minus d. As an example, if I think this is a sub n and this is 19, the one before it is 17. So I could think 19 minus 2. Now I'm doing this in a very general form because I want to create an actual formula. Now alternatively, I could say the sum of the series is equal to the reverse order. I could start out with a sub n and then go backwards. So a sub n plus a sub n minus d, a sub n minus d, plus a sub n minus 2d. I'm just going backwards, all the way until I get a sub 1. Now, by doing it this way, there's something special that can occur. If I group this piece together, I get 2s. I group this piece together, I get a sub 1 plus a sub n. If I group this piece together, I get a sub 1 plus a sub n plus d minus d, and so it cancels, so I get a sub 1 plus a sub n. And likewise, I could go all the way, and you see a pattern, a sub 1 plus a sub n, a sub 1 plus a sub n, a sub 1 plus a sub n. And so the formula is this: 2s is equal to n, the number of terms, times parentheses a sub 1 plus a sub n. And now if I divide by 2, I can say the sum of the series is equal to n divided by 2, parentheses a sub 1 plus a sub n. And we'll also show a concrete problem. So if you're still kind of iffy on what we were doing, we will solve a concrete problem. So that would make more sense. Also, another piece to note is that a sub n is equal to a sub 1 plus d times parentheses n minus 1. And I'll explain this. So let's say a sub n is 19, right? And if you notice, each term is increasing by 2. So 3 is greater than 1 by 2. So 2, 2, 2, 2, and so on. And how many terms do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 terms. So I could say that a sub n, this 19, is equal to a sub 1, 1, plus d. What is d? It's increasing by 2. So 2, parentheses, 10 minus 1. We said there's 10 terms, so 10 minus 1. So 10 minus 1 is 9. 9 times 2 is 18. 18 plus 1 is 19. And so it's a match. And by doing this, I can also say the sum of the series would equal n divided by 2, parentheses, a sub 1 plus a sub 1 plus d parentheses n minus 1. All I'm doing is swapping a sub n for this. And so we would get a sub 1 plus a sub 1 is 2a sub 1 plus d parentheses n minus 1 close parentheses times n divided by 2. And so these are two formulas that can be very useful. And so here's a concrete example of what we just saw. So you know here we use like a sub 1s and d's and like a sub n. It might have been a little confusing. And so here's a concrete example. Same problem, 1 through 19. And each term is increasing by 2. And so here we're going in the forward direction. So 1, 3, 5, 7. And here we're going in the reverse direction. 19, 17, 15, 13, and so on. And so now if we sum these two pieces, and these two pieces, we can see something special. So 2s is equal to 1 plus 19 is 20, 3 plus 17 is 20, 5 plus 15 is 20, 7 plus 13 is 20, and so on. Each combination is going to be 20. And so how many terms do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So we say 2s is equal to 10. And each set is 20. So 10 times 20 is 200 divided by 2, and s is going to equal 100. And so if we use the formula that we got from the last slide, n is 10, parentheses, a sub 1 is 1, plus a sub n is 19, so 19 plus 1 is 20, 20 divided by 2 is 10, 10 times 10 is 100. Okay, so this is a problem that we will go over. So I'm going from 1 all the way to 19, and each term is increasing by 2. Here, I'm not going to count n. So I don't know, if I count it, it would be 10, right? But, what if you have a bunch of numbers, like 100 numbers? You don't want to count n. So this time, instead of counting n, I'm going to solve for n. And so I'm going to use this formula first. A sub n is equal to a sub 1 plus d parentheses n minus 1. I know a sub n, which is 19, and I know a sub 1, which is 1, and I know each term is increasing by 2, so d is 2, parentheses n minus 1. So 1 plus 2n minus 2. So 1 minus 2 is negative 1. Move the negative 1 over to the left, and we get 20. 20 is equal to 2n, and so n is equal to 10, and we can verify it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a match. Now this is very useful whenever you have a bunch of numbers. In this case it's 10. Realistically, we can count 10 very quickly. But if there were 100 numbers, it would be very challenging. And now we want to know the sum of the series. And we will apply the formula. So the sum of the series is equal to n divided by 2, parentheses, a sub 1 plus a sub n. So n is 10 divided by 2, parentheses, a sub 1 is 1, and a sub n is 19. So 1 plus 19 is 20. 20 divided by 2 is 10. 10 times 10 is 100. And so the sum of this series is 100. And you know what? If you want, you can verify it. You can use a calculator and add up all these numbers together, and you would get 100. Likewise, if I want to use this formula instead, I can do that too. So n is 10. 10 divided by 2, parentheses, 2 times a sub 1. A sub 1 is 1. Plus d is 2, increasing by 2 each time, 2, parentheses, n minus 1, and we know n is 10, so 10 minus 1, close parentheses. So 10 minus 1 is 9, 9 times 2 is 18, 2 times 1 is 2, so 2 plus 18 is 20, 20 divided by 2 is 10, 10 times 10 is 100, and so it's also a match. So this form can be very useful if they tell you n, but they don't tell you a sub n. And that's pretty much it for this video.